Hello and welcome. I'm Aaron Cooper. I'm the Senior Vice President for Global Policy at the Business Software Alliance. And I'm really pleased today to have Hasan Ali, who's the Associate General Counsel for Strategic Innovations, where he leads at Microsoft, where he leads the Strategic Innovations legal and policy teams. I got to say, Hasan, that is one of the coolest titles I've heard. And I say that even though both Hasan and I were senior counsel for former Chairman Leahy on the Senate Judiciary Committee, which is also a very cool title. But I got to say, your current one is very cool.
Well, thank you. I actually just got this title. We've had a little bit of a reorg here, but I feel super fortunate to work on some amazing issues at Microsoft. You know, it's not only quantum, which we're discussing today, but also our effort in AI to accelerate scientific discovery, the Microsoft Research Labs. It's kind of the life cycle between like research to incubation to business. So a lot of cool things that you see in this space, and I'm really fortunate to be working here.
So then we're going to need to have you back 5 or 6 times. But today we want to talk quantum because we're starting to see through mainstream media, we're seeing quantum computing breakthrough as a subject. We've seen in the EU, they just came out with a quantum strategy. In the US, Michael Kratsios, who heads up OSTP, even in the first Trump administration, was very bullish on the promise of quantum technology, and we're definitely going to see that as a priority from the administration. Can you start by just talking a little bit about what Microsoft is doing and what its vision is for both the quantum hardware compute and on the software side?
Well, thank you for having me. I think this is going to be a fantastic discussion. Generally, we're super excited about quantum computing. I think the fun part about our approach is that we're fundamentally a platform company, and that means we're not only working across the quantum tech stack, as you mentioned, but we also have some pretty meaningful collaboration with other companies. And I think that's exciting, right? You get to work with the smartest and best folks, both inside and outside of Microsoft, and it's just focused on moving the technology forward. I think I do want to unpack some of the things that we're doing, and you mentioned a little bit there, especially on the hardware side. And we've had a long-running effort to develop quantum hardware, almost 20 years now, to build what we call a utility-scale quantum computer, right? So this is a computer that can actually do something, and this program is spanned across all 3 of our CEOs, which is a really solid endorsement. And I like to say that we've had, kind of a go big or go home mindset for this. For years, we've pursued a pretty unique scientific approach, topological qubits, that many thought was theoretical and couldn't be done. But we kind of pursued this because we think it's the only pathway that can actually scale to a quantum computer. I mean, there may be others, but this is the one that we believe in. And a few months ago, we announced some scientific breakthroughs that's represented in a quantum chip that we call Majorana 1 that had 8 topological qubits, and we think this is kind of a big step forward in what our topological approach, and just to see that it's real and viable. We're also kind of super excited about our partnership with DARPA in this space. DARPA has been evaluating our approach and our progress for over 2 years now, pretty deep technical evaluation. And we're super fortunate to have moved on to the final stage of that program, which now envisions the development of a fault-tolerant prototype computer. But that's just on the hardware side, right? And as you mentioned, we're doing things across hardware and software. And because we're a platform company, we're super excited about our partnerships with other companies, especially with Atom and computing, Quantinuum, Photonic. With Atom and Quantinuum, we've been able to achieve logical qubits, which means what we call kind of a level 2 machine, going past the current NISQ machines into logical qubits that can actually do more in terms of research and development and actually have some application there. And all that's possible because of quantum error correction codes that we're doing. We just released new error correction codes that's making some news. We also have a cloud-based platform to access quantum computers. We announced Microsoft Discovery a few weeks ago, which is going to be the backbone of a lot of this stuff. And we have quantum skilling. So there's a whole bunch of stuff that we're doing, and we're just really excited to be doing it with our partners and in the ecosystem, especially now, right? Because as you mentioned, there's a lot of impetus and movement in the ecosystem, both because of the new administration, because of technological developments like I just discussed, but also because I think the application space is becoming clearer.
really like an all of the above kind of approach where you're
Yeah,
looking at
yeah,
hardware solutions, different kinds of software in order to do error correction on top of it, and then eventually the application layer so people can really make use of it.
yeah. And I think that's the best way to build the technology stack in the ecosystem, right? You want to kind of attack at all layers and make sure that you're driving development forward in a meaningful way, as opposed to kind of just taking it one step at a time. Yeah, we're just really excited about what's going on now and what we're doing in this space.
I appreciate that we didn't talk about this as a ground rule at the outset, but no mathematics was going to be one of them. And we've talked about topographical layers, and we shouldn't get into the Schrodinger equation at any point during this. But I appreciate that. One of the things that you mentioned was that we're getting closer to the point where you can have fault tolerant quantum computing, and we can deploy it in the real world. What do you see as some of the real world applications as this really starts to take off?
Yeah, that's a great question. And of course, kind of the most cited application for quantum computers is cryptanalysis, and that's driven a tremendous amount of interest from the national security establishment, and also because of the geopolitical implications of that. But we think quantum computing is transformed across so many areas, and the biggest application space that we see is chemistry and material science, right? And that sounds like a niche area, but it's really about everything, right? Chemistry and material science is about what we touch, what we feel, what we eat, what we wear, what we use. And just look outside the window, all of nature is chemistry and material science. And what we're excited about is the ability to move from trial and error chemistry in the wet lab to really predictive chemistry. And we think that's going to be a game changer across industries, right? So from like energy to agriculture to drug discovery. But the big key here, I think, is making sure that the technology actually has global impact, right? One of the things when we talk about AI, for example, and you've probably heard us say this before, that we think AI is what we call like general purpose technology. Everyone's using AI and everyone should use AI. Quantum's not going to be general purpose technology, right? You and I most likely will not be using a quantum computer, but we want to make sure that the impact is global, right? And that's what we're really also kind of focused on at Microsoft. When I first started supporting the quantum program, the unofficial motto, which is really what attracted me here, was save the world, feed the world, right? Because it is this ethos that you can use this technology to have transformative impact beyond just kind of the local space. So some really exciting stuff that we think quantum computing can do, and we're excited to move it forward.
That's really exciting. And you say you and I are not going to use quantum computing. That's because there are some kinds of applications which traditional software and traditional compute power just works better. You don't have quantum supremacy, or you don't envision that as part of the use case for quantum.
Correct. And also it's just really expensive to build a quantum computer and use a quantum computer, right? So, we're not only the technology not support, us playing Minecraft or, surfing the internet, but, you want to use it for the most impactful applications. And their chemistry, material science, drug discovery, other applications like that will really have an impact.
But we talked a little bit at the beginning about how governments in different places around the world are starting to look at quantum strategies in order to try to make sure that they're developing and thinking about how to get to the point of deploying quantum compute capabilities. If you could wave a magic wand and get policymakers to do one thing, what thing do you want them to focus on?
It's a really good question. I think the biggest challenge that we have is how we talk about quantum computing, right? There's been a lot of exciting tech developments. I just rattled off so many, and especially over the past year from companies like ours, from Google, from others. But given the transformative potential of the technology, I think there's just a lot of hype as well. So we need to make sure that we don't let that excitement lose sight of not only where we are, but where we have to go with the technology that we have. We have to kind of cut through the noise. And that requires us kind of developing, a common lexicon, a rubric, putting emphasis behind the evaluation and benchmarking programs like DARPA is the one that I mentioned, right? And that's why one of the reasons why we think DARPA's program is so critical. That type of deep evaluation does help kind of clarify where we are and clarify, which approaches are kind of cool science projects to, ones that can go the distance and actually come out to technology that real people can use. So I think that's kind of like the big key here is like there's just a ton of excitement in this space, which is entirely appropriate. In fact, you've probably heard a lot of excitement from me right now on this. But we just want to make sure that we're also grounded in where we are and where we have to go.
And it's an intimidating phrase, quantum computing, and I think the way artificial intelligence might have been 5 or 6 years ago, but now in different use case scenarios, we're used to using Copilot and other tools that over time trying to find industries that really can benefit from quantum computing, making sure that they are prepared and are ready to start adopting some of the solutions. Are there things that you think policymakers can do to help prepare those industries to be ready in order to take advantage of it? That's sort of one of the things that's going to drive competitiveness, it seems to me, in different industry sectors, is who's ready to take advantage of it when you get to a point where it has supremacy over classical computing.
100%. That's so important, right? I mean, as the technology develops, we also have to make sure that governments and industries alike are positioning themselves to be first movers in this space, right? Like it's going to take some time to understand quantum algorithms, the application space, but also the industries and the skill sets going to be needed to move this forward. So we talked about chemistry and material science, right? Having computational chemists, right, understand quantum computing, but also what can be done with AI and HPC today. One of the reasons that we've developed the Microsoft Discovery platform, which does use AI and HPC today to accelerate scientific discovery, is because it's the lead into quantum computing. You can use these tools right now, understand where quantum will actually be beneficial and have the most impact, and then move that forward. So what we do when we talk to governments is not only focus on tech development, but also ecosystem development at the same time. And that's quantum skilling, not only with PhDs in hard technical sciences, but also skilling just across the board in the industries that are going to make a difference in the future.
That's another lesson we've learned from AI, that we both need data scientists, we need coders, but we also need people who are going to make use of it to make sure that in retail, in the pharmaceutical sector, in the chemical sector, in manufacturing, they're ready to adopt and use it in order to be competitive in the global marketplace.
Yeah, just as I'm learning prompting right now and making sure I put in the right inputs to get the beneficial answer, we need the exact same thing in quantum too, right? So all this is going to be a long-term effort, but the good thing is we have time to kind of start that process right now. And with level 2 machines, with other things that are coming online, I think the future is super bright.
Thank you. Thank you so much for joining. We really appreciate your taking the time today.
Absolutely.